is a collaborative project with Indiana University where we are working with a team of physical therapists, together sponsored by the NBA and GE, to look at tibial stress fractures in basketball players. Generally speaking, bone is a complex material that constantly renews itself over our lifetime. And there are certain time frames as we get older in the lay population, and then even in younger groups, in particular in athletes, where that process can get muddled up in terms of overall fracture strength of bone. In the case of basketball players, they are a susceptible group to tibial stress fractures. In order to investigate the mechanical response of bone to different muscle forces, we can really only do this using non-invasive methods, so that involves computational techniques. To start that pipeline, we collect motion capture data, so this is where you put the dots on people, and then have a series of cameras recording the movement of those dots for a variety of different tasks: walking, the lateral cut, that exercise that they do, or the jumping that results from a layup. We can combine all of this data that's collected at the Gait Laboratory at IUPUI. So we take a CT scan of their lower limbs, and then the CT data, the motion capture data, gets sent to us, and then we use some of the computational resources that are strong here at U of I to develop the computational models. The gait data gets turned into a musculoskeletal model that lets us actually predict what the muscle forces are dynamically during the task of interest, and then we can combine those two together to then get an idea of what the mechanical strain in the bone is using finite element models based on those CT data. We hopefully will identify the role of fatigue, and we will be able to come out of this with a set of guidelines that says if you do this and you don't allow the bone a rest time to heal, essentially, after you undergo some strenuous activity, this is going to put your players at risk. We'll also provide more quantitative evidence of the importance of the muscle-bone interaction. And this could then have implications in terms of exercise programs in general if we want to maintain bone health lifelong.